Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2537. Count the number of good subarrays. This problem is based on two pointers and asked in Amazon and Uber. Marked as medium. Let's try to have a look on the problem statement. We are given an integer array nums and an integer k, and we have to return the good subarrays from nums. This is our problem statement. Now what is good subarray? A subarray ARR is good if there are at least k pairs of indices such that I is less than j and array of I equal to array of j. In short, they want to say that there should be k pairs where both the values are equal. So if we have these pairs, that subarray is called good subarray, and we just have to count all of those good subarrays. Subarray is like contiguous non-empty sequence of element. Now let's have a look on the example. Before that, if we have a look on the constraints, the length of the array will go till 10 to the power 5 and the elements are going till 10 to the power 9. Now example is what is given to us? This array, apart from that this integer. This array is given to us and this integer is given to us, and what we have to figure out is count good subarrays. And good subarray is a subarray, let's say any subarray, where we are having at least k pairs where the values are equal. So if I just have a look here, 3 and 3, this is forming one pair which is having both the values equal, yes, and this is also forming a pair. So this is a good subarray. This is something we have to find out. First of all, if we try to think of a brute force solution like figuring out all those subarrays, then this might not be possible because we are having a very high constraint, that 10 to the power 5, and if we go n square it will be like around 10 to the power 10, which is not feasible. So let's try to think and build our subarrays. Let's say I start from this. Is this valid? No, it is not valid. If I just try to expand it, then it is also not valid. Expand it further, not valid, not valid, not valid. In this, so far we are having only one pair which is equal, but we require two pairs. And if I try to expand it further, now I have two pairs, pair 1, pair 2. So starting from 0 till this index, we are having a valid subarray, right? So if it is a valid subarray, it means good subarray. So good subarray count will be equal to incremented by 1 plus equal to 1. Okay. Now if this subarray is good subarray, it is good because we are having at least k pairs with equal element. Now if I just try to expand it further, this array will still be good subarray because those pairs will always be there. So it doesn't matter that what is my right pointer, what I'm choosing. The array, if the array is valid, it will always be valid if we try to keep on expanding it. It shows that if I have to capture it, let's say I'm maintaining two pointers. Starting pointer, I'm starting from index 0 initially, and let's say this is my ending pointer. Ending pointer, when I come to this index, the array is becoming good subarray. If it is good subarray, it means all the values of j after this will also be a good subarray. So if I just mark the indices, let's track the indices as well. 0, 1, 2, 3, 4, 5, 6. If the value of j is 5, it is valid. It means value of j is 6, it will also be valid. So how many elements will be there starting from j till the last element? See, last element is n-1 and current element is j. And what is the length? What is the size of elements in this window? 2, 4, like starting from j till the last element. We have to include the j as well and the last element as well. So it will be last element minus j plus 1. So in short, it will be n minus j elements. So if I encounter the first valid subarray, that valid subarray is not going to contribute 1 to the answer, and it is going to contribute this to the answer. It means that we are capturing every possible value of j. But we are starting from I equal to 0. So we are fixing I in this case. We are checking for every single possibility of I for every single possibility of I, check all the valid possibilities of j. In this case, we are going to capture every single combination of I and j. So here my answer won't be incremented by 1, it will be incremented by n minus j. So n minus j good subarrays I will be having. Okay, so I just told you that see, we are going to capture every single possibility of j for I equal to 0, right? In this case I did for I equal to 0, I check every single possibility of j. So if I equal to 1, I check every single possibility of j. I equal to 2, I check all the possibilities of j. In this case, I'm going to get my answer for every single possibility of I and j. So here I got an idea that I will be starting and fixing my I pointer, and then I will be searching for the first j pointer where the subarray is good subarray. And for the good subarray, what I need to do is I need to maintain the same pair count which are equal. I will just take the same example here, 314, 3224. So here I got an idea that starting from I will go from 0 to whatever value you want to get. So I will start from 0, and for every I, I'm going to capture every single j. Every single j means I will be going for the first valid j, and after that every item or every pointer is valid. So in this case I started from I equal to 0, and when j was 5 it became valid. So it became valid for 5 onwards, greater than equal to 5, all the value of j are valid. So this is something we have to figure out. So here I got an idea that I will be maintaining 2 pointers. First pointer is I, and for every I am maintaining my j pointer, and then I will keep on capturing until I find the valid j. I'm going to add n minus j to my answer. Good subarray count. Good subarray count plus equal to n minus j. I hope you understood this equation, because every single element starting j is valid. Now how do we get to know that this is good subarray? It is good subarray if the same element count, same element pair with both the element are same, are greater than equal to k, at least k. So in any subarray, if the count of same element is greater than equal to k, then that subarray is good subarray. And for that, what I can do here, 3 is there, 1 is there, 4 is there, 3 is coming twice. If 3 is coming twice, it means it can form a pair. 2 is coming 1 time and 2 is coming 2 times. 2 is coming 2 times, it can form 1 pair. It means to form one valid pair, I need to have 2 elements. Now if I introduce one more element into this, so this one more element will also be able to form pair with every single previously captured element, right? Let's say in my subarray I am having 3 here, I am having 3 here. This is one pair I am already captured. If I encounter 3 again, it means this 3 can form pair with these 2 elements already captured. So here I'm getting an idea that I need to capture the frequency of every single element. So far we have decided that I will be checking for every single value of I, and for every value of I will try to get the first valid j. Let's say j is at this position. If j is at this position, then just capture the frequency. 3 is coming 1 time, and 3 is coming 1 time, and the current same element pair I will just capture in a variable, so that I will get to know directly that when my subarray is getting valid. So currently same number of element pair are 0. When I am moving my j pointer, 1 is coming 1 time, moving my j pointer, 4 is also coming 1 time, 3 is coming 2 time. 3 is coming 2 time, it means 2 elements are forming 1 pair. Instead of thinking like this, what I can do is, if 3 is coming again, whatever is the previously captured frequency, this 3 is going to form pair with all the elements which are previously captured. So for one element are there on the left side, so this 3 is going to form pair all the 3 occurrences captured so far. So 3 is going to form one pair, so same will be incremented by 1, and then I am getting 2. 2 is coming one time. Now again 2 is coming, so this 2 is going to form pair with previously captured 2. So here in this case I will increment 1 as well. Now my same value is 2. If my same value is 2, which is greater than equal to k, in this case I have to stop going further. It means this j is valid. So this is my valid j and my I started from 0. So this is something I did. I kept on going for a specific value of I kept on going until I find the valid j. So what I did in short, if I try to write a pseudo for this, first of all I am maintaining a pointer I which is going from 0, let's say it is going till n-1, and then my first step is find a valid j, and the valid j will be when the same type of element is crossing k, greater than equal to k. No, not the greater than equal to k. It will break the loop if it is greater than equal to k. If it is less than k, just keep expanding j. This should be the case. Apart from that, j should also not go out of bound, j less than n. Okay, so until I find a valid j, keep on capturing the element. First of all, capture the frequency of the current element. Now I am at a specific index. Let's say j is here in this case. For j equal to 4, first of all I need to see whether the 4 is already captured in the map or not. If it is already there, whatever the number of element of 4 in the map, I'm going to have the same number of pairs. So first of all, like same plus equal to map dot get whatever is the value of j. So this is same pair I'm going to get. After that, increment the frequency of current element by 1. So map dot put whatever is my current element, just frequency, previously captured frequency plus 1, and after that just increment the j as well. So this is something I need to do. Firstly, I did every single element for I equal to 0 to n-1. The first step I did is go to the valid j. Now this loop will be I will come out of this loop, and this condition will become false when the same count will become equal to k. If the same is becoming equal to k at this moment, for this subarray I need to capture every single possible value of j starting from j onwards. So starting j onwards, this is also going to give me one subarray, and this is also going to give me one subarray. So ultimately the total subarrays I need to capture is n minus j. It means when I'm coming out of the loop, here my subarray is valid from I to j, but I need to capture every single j for corresponding I. So good subarray count plus equal to n minus j. I need to do something like this. So subarray count is also captured. So now what is the third step? Third step is we are incrementing I. If we are incrementing I to 1, I need to reduce this value from my captured frequency map. So map dot put current element, which is I, and the frequency minus 1. Frequency will be updated to -1. Current frequency minus equal to 1. So as I have updated the frequency, this might also affect the same count, same number of element count. If after reducing the frequency, there can be two possibilities. If the frequency is 1 will always be there because I is already captured. If the frequency is 1, I just reduce it to 0. It means it is not going to affect my same counter. Same counter is the count of the similar element. But if the frequency is 2 or greater than equal to 2, it is reduced to maybe 1 or greater than equal to 1. In this case, it is going to affect the same counter. So I will just check if the frequency is there. If map dot get I is greater than 0, my same count will be decremented by 1. So similar to this, I need to form our formula. So this is like a pseudo code. If I just try to do the dry run, let's apply the same example. 314 3224. 314 3224. Firstly, do the initialization. I is equal to 0 and j is equal to 0. I will be maintaining a frequency map. In the frequency map, apart from frequency map, I also maintain a counter which is same. And apart from that, good subarray count is also there. Initially, just keep on expanding the window, keep on expanding the j pointer until we find a valid j. Just capture the frequency of current j. 3 is coming one time and then move j. 1 is coming one time, move j. 4 is coming one time, moving it. 3 is coming 2 times. So 3 is already there in the map. 3 is already there in the map. It means same count will be incremented by current frequency, because this 3 value is going to form pair with every single element I captured. So same is 1. Same was initially 0, it has become 1. Now the frequency of 3 is incremented to 2. Next element is 2. 2 is coming one time, and this 2 is coming one time, but this 2 is already there, so it is going to contribute 1 to my same. So frequency is 2 here. Now the same value is 2, because my k value was 2. The same and k is equal. It is the time to capture the result. This is the last valid value of j, and this value and this value will going to contribute to my answer starting from I equal to 0. So good subarray count will be incremented by n minus j. So initially it is 0. From 0 it is incremented to 2. And this is something we captured for I equal to 0. Now I equal to 0 is done. We have to increment I to 1. So I is incremented to this one and j is still at this position. When I incremented I also need to reduce the value. See, value of 3 should be reduced to 1. Now value of 3 is reduced, but I also need to check whether this 3 was contributing to my same or not, because as after the reduction, the same after we have reduced the frequency of 3, it is still 1. It means definitely it was contributing to the same. So what I have to do is, one value I have removed, and this one value was forming pair with every single element which is here, right? So whatever the current frequency, we have to reduce it. So in this case, in our above pseudo code, I just do not need to remove only one. Same minus equal to map dot get I. Frequency I need to remove. If I have to remove the frequency, just no need to check the counter. See, so what I have to do now is just reduce the frequency, and whatever is the remaining frequency, just reduce that from the count. So this 1 will be removed from the count. So count is 2 minus 1, which is 1. If the count is 1, which is not equal to k, I have to increment by value of j. So value of j will now be at 4, and increment the frequency of 4. 4 frequency is becoming equal to 2. So all of the previous frequency, which is 1, is going to be contribute to the same variable. Same variable will be updated from 1 to 2. And now this 2 is equal to k. I need to capture the answer. Starting from I equal to 1, I need to capture the answer. J is already at the last position. So n minus j. J is n minus 1. So it is 1. So GSC is getting one more into the answer. So it is from 2 to 3. So good subarray count has become 3, right? If the good subarray count has become 3 and I have captured all the good subarrays starting from I equal to 1, I will just try to capture it from I equal to 2. I equal to 2. So when I incremented from I equal to 1 to 2, the frequency of 1 is reduced. So frequency of 1 is reduced from 1 to 0. It means 0 number of same pair I need to reduce. So same pair will remain same. 2 minus 0 is equal to 0. So same pair is 2. Even after moving I to 2 and j is still at the n minus 1, I still have same count equal to 2. So just capture this as well. So j n minus j, which is 1 need to be captured at this position. So it is 4. Now I will just try to capture it for I equal to 3. For I equal to 3, I reduce the frequency of 4 in this case. Reducing frequency of 4 from 2 to 1. 2 to 1, I reduce the frequency of 4 from 2 to 1. It means whatever the remaining frequency, 1 count should be removed from same. So 2 minus 1, which is 1. Now the same count is reduced. When I'm moving I equal to 3, in this array, the same count is reduced. The same pair which was 4 and 4 is now outside and we have only one pair, 2, 2. But this is not matching with k. It means we are not going to capture it. If there is if I equal to 3, if there is no scope, then there won't be any answer after this, because there is no scope of incrementing j. But in this case, let's keep the loop running. For I equal to 4 also, I'm not going to get any answer. For I equal to 5, I'm not going to get any answer. I equal to next onwards 5, I won't get the answer. So yeah, the loop will keep on running and it will close once I crosses n. So yeah, I'm get the answer. The answer will be 4. So this will be the code. First of all, I am fixing I, and for every I, just try to figure out the minimum j. And minimum j is something, it is going to give answer starting j onwards after every single position. At j, I'm going to get the answer. At j plus 1, I'm also going to get the answer because my pair count will remain same. So just capture for every single possibility of j. That is n minus j I'm going to capture. After that, just keep your I by 1 and check the frequency now. So two variables we need to keep track of: the count of same pair and what are the elements we need to capture, that is n minus j. I hope you understood the approach. Now let's try to write the code for this approach and see if it is getting submitted or not. And what about the time and space complexity? See, I am moving my I pointer from 0 to n minus 1, and j pointer I'm also incrementing parallelly. So it is order of n time complexity. And what about space? Space I am taking to capture the frequency. Order of n time, order of n space. Now let's write the code. Here I will be requiring a map. Before that, let's capture the length of this nums array. Nums.length. I will just take a map of integer capturing the frequency of every element in this nums array. Map equal to new hash map. Okay, map is captured. I will require some variables. Int same, count of same pairs. Initially it is 0. Count of good subarrays, initially it is 0, and my j pointer will also be 0. I will be looping over the I pointer, I equal to 0, I less than n, I plus plus, and here while it's not valid, make it valid, then capture it, move forward, or in short you can say done with current I. While it is not valid, it will not valid if same is less than k. If same is less than k, it is not valid. I also need to take care of the stuff that j is not crossing n. Now we have my current window from I to j, and j is for sub array starting from I equal to 0. So I need to capture the frequency of j in the map. But before capturing the frequency, the current element that is going to be captured might make some pairs from previously captured elements. So I will be updating my same score plus equal to map dot get or default. Get or default for nums of j, and it is 0. What does this line mean is, for jth element, if there are already some element, let's say already 2 occurrences are captured and this is the third occurrence, so it means the third occurrence is going to make pair with those 2 captured elements. After that, just update this value in the map as well. So map dot put the value of j, or whatever is the value of whatever the previous value of j, plus 1. After this, j plus plus. Now let's say this is my last j, where first j I'm getting the valid subarray. After this, in the last iteration, this is also incremented, so I need to adjust this as well. And I'm going to capture only in the case where my same value will be greater than equal to k. And what is that capturing? N minus j. But in the last iteration, they are giving me one incremented value of j, so just adjust that as well, plus 1. In short, what I'm doing is j minus 1 and minus j minus 1. Now I'm done with I. Just reduce the frequency. Map dot put nums of I, comma map dot get nums of I minus 1. Whatever is the frequency of nums of I, just reduce it by 1. I have reduced it by 1. It means that one item that is reduced was forming pairs with the existing elements. So whatever is the existing element that I have to remove from the same, minus equal to same minus equal to map dot get nums of I. This is our logic. It's like a sliding window 2-pointer approach. Make it valid and capture all the valid elements, and then try to move forward to capture all the subarrays starting with I equal to 1. Here, yeah, that's all we have to do. In the end, just return count of good subarray count. Let me run over sample test cases. I'm getting wrong answer, or this might be because of the overflow. Let's try to keep my good variable answer variable as long, because they are also expecting long from this function. So this good was initially 0 and it is being captured here and returning here. Now let's submit it again. This time it got submitted successfully. I hope you understood the approach. In case you get any doubt, just do let me know in the comment section or in the Discord community. Bye bye. Thank you guys.